Good morning, grade 6. Welcome back to grade 6 mathematics class. Hope you all are doing great today. Let's learn about quadrilaterals today. What is a quadrilateral? You can say it is a simple, closed, four-sided polygon. So a quadrilateral is a polygon with four sides, four angles and four vertices. A square is a quadrilateral, a rectangle is a quadrilateral, a parallelogram, a rhombus are quadrilaterals. Now here you can see quadrilateral ABCD. So this is a four-sided polygon. Now how do we name a quadrilateral? See, this is quadrilateral ABCD, not ADBC. So when you name a quadrilateral, it's important that you take the right order of the vertices. So this is either quadrilateral ABCD or ADCB or BCDA, like that. Now you see the line segments forming this quadrilateral. Which are the line segments that form this quadrilateral? Line segment AB, line segment BC, line segment CD and line segment DA are the line segments that form this quadrilateral. So these line segments are the sides of this quadrilateral. So there are four sides. Which are the four sides? Line segment AB, line segment BC, line segment CD and line segment DA. They can also be called side AB, side BC, side CD and side DA. So these four sides of the quadrilateral also enclose four angles within the quadrilateral. So which are the four angles of this quadrilateral? So let's see the four angles. So there is angle ABC, which is this one. There is angle BCD, which is this one. There is angle CDA, which is this one. And there is angle DAB, this one. So these are the four angles of this quadrilateral. Now, you see this side AB and side BC has a common point, which is vertex B. Now the side BC and side CD have a common point, which is vertex C. The side CD and side DA has a common point, the vertex D. Now the side DA and side AB has a common point, which is vertex A. So these are the four vertices of the quadrilateral. So which are the four vertices? Vertex A, vertex B, vertex C and vertex D. Now the side AB and side BC have a common vertex B. So when two sides have a common vertex, we say they are adjacent sides. So side AB and side BC are adjacent sides. Side BC, side CD are adjacent sides. Side CD, side DA are adjacent and side DA and side AB are adjacent. Now see these two angles, angle ABC and angle DAB. These two angles have a common arm or a common side, which is side AB. So when two angles share a side or an arm, we say those two angles are adjacent angles. So angle DAB and angle ABC are adjacent angles. So this angle DAB can also be called angle A. Angle ABC can also be called angle B. Now angle A and angle B are adjacent angles. Angle A and angle D are adjacent angles. Angle D and angle C are adjacent angles and angle B and angle C are adjacent angles. Now the ends of the same side or the vertices that come on the same side are adjacent vertices. So vertex A and vertex B are adjacent vertices. Now what about vertex B and vertex D? They are not on the same side. They are not the endpoints of the same line segment or the same side. So vertex B and vertex D are opposite vertices. Vertex C and vertex A are opposite vertices. Similarly, angle B and angle D are opposite angles. Angle C and angle A are opposite angles. Now, if I draw a line segment from one vertex to the opposite vertex, that will be a diagonal of the quadrilateral. So here the line segment BD is a diagonal of this quadrilateral. the line segment AC is also a diagonal. So how many diagonals can we draw inside a quadrilateral? We can draw 2 diagonals inside a quadrilateral. Now, you see the shaded region enclosed by this quadrilateral, that's called as interior. So, if I mark a point M inside this region, we can say the point M is in the interior of this quadrilateral. Now, the portion or the region outside the space enclosed by the quadrilateral, that's called the exterior of the quadrilateral. So, if I mark a point X here, I can say the point X is on the exterior of this quadrilateral. So, I hope these are clear to you. Now, let's see a few examples of quadrilaterals. So, here you have got some pictures here. The first quadrilateral is a square. So, a square is a quadrilateral with 4 equal sides and 4 equal angles. You see the angle between any 2 sides of a square will be 90 degree. So, inside a square there will be 4 90-degree angles. So, the total angle measurement will be equal to 90 degree into 4, which is equal to 360 degree. Now, we can see the opposite sides of a square are parallel. Take any 2 opposite sides, the sides will be parallel and equal in length. Now, what about a rectangle? A rectangle is another quadrilateral in which the opposite sides are equal and parallel. So, in a rectangle also, the 4 angles will be 90 degree each. So, the total angle measurement will be equal to 360 degree. Now, the next one is a parallelogram. In a parallelogram, you can see the opposite sides are parallel and equal. We can see a few more examples of a quadrilateral here. The next one is a trapezium, the next one a rhombus, and the next one is a kite. So, these are all quadrilaterals which have got their own properties. Let's see the properties of quadrilaterals in general. So, quadrilaterals will have 4 sides, 4 vertices and 4 angles. And we can draw 2 diagonals for a quadrilateral. Also, the sum of all interior angles, which means the angles which are enclosed by the 4 sides of the quadrilateral. The sum of all the interior angles of a quadrilateral will be equal to 360 degree. So, that was about quadrilaterals, children. You have to go through this topic once again, which is given from page number 166 of your textbook. So, once you have gone through that, you will be ready to do exercise 11.5. This is in page number 168. In the same page, you can also see a horse exercise, and there are try these exercises given in the same page. Please go through all these activities and do accordingly. Once you are done with the answers, please do take a picture and send us through Teams. So, that's all for today. We'll see you in the next class with a new topic. Till then, bye.